into the estimate, hoping that that buffer should help them to take care of it. So there is no tangible approach or a framework in which they will be able to measure this NFR. We will see how to measure this down the line. We have a small calculator which we can show you to estimate this effort. Right. So these are some of the typical myths involved. And how does a framework help here, right? Software framework typically is any reusable software platform which can be used to develop any kind of application, any kind of product. And we saw in the earlier slides that we saw an adjoining requirement with overlap of 60%, right? And then the other two runtime and maintenance requirements overlapping up to 80% of it. So framework typically concentrates on this commonality between these various products so that people need not put their minds reinventing the same wheel again and again. So that's essentially a framework is all about. And it focuses mainly on the non-functional requirements, right? So which in turn will increase the productivity, will be like booster when it comes to developers being able to develop functionality on top of it. And it also kind of demarcates the job, right? It clearly demarcates the developers from focusing on the functionality versus architects focusing on the overall design of the project, right? So it gives a nice demarcation as well. And very simply, developers can now just focus on just developing and debugging instead of trying to do the underlying plumbing related work which they are not well suited to do. Now, why do I need a framework, and what if I don't have one? There is a set of challenges the team undergoes when they don't have a framework, which you have seen in several projects, in several customer cases. One is developers, they need some place to get started. What happens particularly in agile kind of projects, there's one other common mistake people do that, okay, I'm doing an agile project, so I'm going to start by sprint. So I'm going to take the first sprint, I'm going to take some functionality, start building it, and then I'm going to keep doing it in pieces, in chunks. That's what agile is about. But they fail to understand that agile also indicates that the sprint 0, which is the first sprint, should focus on the architecture of the project. Right? You need something, some base, which has to be given for the team to be able to start working on top of it. Right? So developers need something in the first hand to be able to get started. And they also have difficulty when it comes to the step-by-step things as to what is required to build a successful application, right? So where do I start, what kind of technology should I use, and how do I glue all these different pieces together? So they are often kind of left to make decisions on their own. Sometimes it goes wrong. And more importantly, developers are under time pressure, so every project has its own constraints. So they end up taking up shortcuts. Right? They don't tackle it at a design level, but they rather try to tackle it at a code level. So if it's a security thing, they don't think through across the system. Instead, they do a simple if condition check for that page, hoping that that page now works well for security. But the point is the entire system should be secure, right? And it also opens up a scenario where every developer or many of the developers try to solve the same technical problem, right? So they try to do security check in their own style. Every developer comes out with their own style. And overall, it ends up with an application which is extremely hard to maintain and extend as well. So what is the framework and how does it look like? Well, this is an example of a SaaS framework. We have taken an example of a SaaS framework here. So as you could see, you have a plumbing stack here which deals with all the common plumbing related things like how do you handle exception, right? How do you do logging? What is the mechanism for auditing? All these things, if you look, are common, right? Every developer is going to handle this piece of it. Now, instead of having them do it, you tell them that, okay, these are the various libraries available. So if you want to do an exception handling, you use this. There is also enterprise library which could be used here. So we keep that apart for now, for the side for now. But the point is, when it comes to all these basic operations, utilities, make it available as a stack to them. And then there is a set of engineering related stack which is very particularly done for SaaS related projects, like multi-tenant or which could also be used for enterprise related applications. So when you work with applications with high configurability, this framework has a configurable UI, for example. which takes care of UI level customizations. And then there is a custom workflow builder. So in case if you are doing a workflow, you could design workflows according to the customer using this module, right? And then you have the user management, the ability to track various events within the product, the ability to schedule tasks within the product, notification, for example, being able to send out notifications to a lot of people through the form of emails or FTPs, right? So all these again are common things, and each module does a particular job. These modules can be used by the actual product, and the product itself sits in the top. If you see in the top, you see the product specific functionality. That functionality can utilize these modules, which means they don't have to think through how to do a roles and rights management. They don't have to think about how do I handle with configuration of my UI, right? It's all taken care already, so the product functionality can move faster. And in this particular framework, all these engineering stack works under the context of tenant. This is a SaaS multi-tenant framework, so it applies the multi-tenancy at all levels. So you know exactly which customer has done what customization, right? So which tenant has done what settings. That is always kind of tracked, and then only that particular information is retrieved or acted upon. There is also a SaaS operational related component which provides a set of modules that deal with the management of the SaaS product itself, right? Like we saw, this is no way a direct functionality of an end user, right? A tenant provisioning is basically a feature that will allow you to add a new customer into your system. Now this is purely for your own operational efficiency sake, right? The end user is not going to be using this feature, but then the operational guys of the ISV or the organization that is having this product is going to use this. Similarly, licensing, how do I package my product differently? How do I consume, or how do I meter the consumption of my product so that I can bill my customers according to the usage? So again, these are things which are done at the operational level. Now, how does a framework help? And one, as we saw, it gives the focus on the functionality, the product functionality, instead of the underlying plumbing layer. And we just saw that the duplication of effort now is no more a reason, because you have done all the common things and made it available to the team. So it's a matter of educating the team to tell them what to use in what scenario. So the rework percentage comes down drastically. And then the estimation accuracy goes up pretty high, because now developers are much more comfortable in estimating the functional requirements. And the non-functional requirement itself is taken care by the framework. So they know it very clearly, and they give you a more optimal estimation, which again will be very helpful when it comes to fix the project. And reusability of the code, which is already pre-built and pre-tested. So if you take an existing framework, then you already have it well tested and available. So you don't have to really spend time on that again. So the time can be focused only on the functionality, and then the whole reliability factor also increases. And the more important thing the framework also kind of establishes is the practices, best practices, right? So nothing like doing things correct in the first time, right? That's the best way to finish a project quickly. Now this framework also establishes a set of engineering standard, a set of programming practice, so everybody knows how to implement a certain security norm. So they do it in a uniform way, in correct way, right? So things becomes much more easier to handle. And also the NFR being focusedly addressed within the framework provides you an avenue where if things change tomorrow, for example, the security model has to be changed, then you have to just change it within the security model of the framework instead of going and changing it across your products. So handling changes becomes much more easier and very cost effective. And overall, this framework reduces to a great extent the technology risks, the technical risks which we saw in the earlier slide related to extendability, testability, I got an unstable architecture, performance related issues, scalability issues. So those are the things, risks that are now addressed by the framework itself. The other advantage from a services organization perspective is you do several projects, right? And several projects, like I said, the domain or the functionality of those projects could vary, but the non-functional requirements will still remain the same. So when you take a framework approach, you give a standardization of the technology itself, right? So you decrease cost to a great extent because the same thing can be used again for your next project. So then the overall estimation of the next project, if you look at, drastically comes down. It gives you a very good competitive edge. And you also end up having developers who are comfortable with the framework. They would have used it, so they know exactly how it works. So the next project goes very smooth because they are not forcing any new surprises over there. They know exactly what to do. You get a tested and proven framework and you do this repeatedly. And at the end of the day, again, reduces the technical risk. Now, having understood on the framework side, what does it take to build a framework? Well, it does take a bit of investment, but it's worth investing because you are going to be ensuring the success of the project at the end of the day. Looking at the skill set level, this chart kind of gives you a high level information on what are the various skill sets required across the phase of building a framework. Now, framework development itself has to go through almost an SDLC. So you have to collect your NFRs, you have to design for it, do an architecture, you have to code for it, and then you have to do a testing of the framework. Now this has to be done like independently almost, so that you are sure about the framework and it's working. And you see the kind of skills that are required. So predominantly, if you look at the architecture and design phase, is where your technology people will be required, tech leads and tech archs, to be able to come out with a solution. And this again shows the kind of effort that is required from the senior people. So if you look at 25, 16, 19, almost 60% of effort has to come from the tech arc, tech lead, and the senior engineers in the team. So that's the kind of effort that should come from that senior people team in order to be able to come out with a successful framework. And then comes the question of, do I need to necessarily build my own framework? Having seen the amount of effort and the senior people availability to build something like this, is it required that I need to build it by my own? You can take that approach. Some customers take a custom development approach where they want to have full control and they want to develop it from scratch. Of course, it takes a lot of time, but they have their own control of every single decision. As an alternate, there are also several frameworks that are available in the market that can address various types of NFR requirements. Right? Now, so we'll particularly pick up the Cello framework. Cello is one such framework. It's a multi-tenant application development framework. In fact, the framework slide we saw earlier is actually from the Cello product itself. So it comes with a set of engineering and operational modules like we saw in that slide. And Cello particularly can save anywhere between 30% to 50% of the time and cost which will have to be spent in building a typical project, a typical application or product. Right? So it's a straightforward calculation. Right? You can think of 30 to 50% of cost saving, what it can do for a competitive bid. Right? So you can quote at almost half the price of what your competitors are going to quote. So that's going to put you across in a different level altogether. And this framework approach also will be well received by the end customers because they see a value add coming through this. It's not just you are cutting down the cost for the sake of winning a project, but also you are bringing a value add to the table by bringing a robust architecture and framework. And Cello particularly uses .NET technology, and therefore there are no additional learning curve for developers. And it yields a very high return of investment, an ROI which can go as much as 150K USD on your budget. Right? So that's the that's the framework part of it. Now we will also quickly take we'll also